here has ever written any code? Raise your hands, please. There's a couple liars here. Keep your hand up, please. And who came back to that code after a couple of weeks or months or days to work on it? Maybe you had to add more features. Maybe you had to do some maintenance on it, bug fixes, whatever. Any reason why? It's probably pretty much everybody. If you didn't raise your hand, you're probably lying, or you're lucky enough to be writing throwaway scripts, which is my favorite thing to do, to be honest. And I want you to think about how you felt about that code. Right? How did you feel when you got back to that code and you looked at it? Did you think that what you wrote was good, that it worked well, that it solved the problem correctly, and that you could keep that code forever? Or did you lean towards thinking that the code was actually pretty bad? But would you have maybe done everything differently if you had a chance to do it over? And it doesn't have to be like a very big feature or like the entire app. It could also have been like just one class in your project where you go, this class just does crazy stuff. It should have been completely different. And why do you think you felt that way? Because I've been thinking about this a lot in preparation for this talk, but why do I feel the way I feel about the code? And how has that changed over the years? Because after some conversations with people and thinking and reflecting on my own stuff, I realized that as I became more skilled as a developer, I got happier and happier with my code. And not because I think the code was necessarily much better. It's more that I learned to accept that sometimes the code just isn't exactly what I wanted it to be. And sure, you do have better insights and you're better at solving problems and using the right tools. But I also realized that as I was more junior, I was typically just writing code and then continuing to learn, and then wanting to change everything I did because I learned so much more either about Swift or about iOS development or about a framework that I'm using. In fact, just the other day I was having a conversation with Daniel, for example, who I would consider to be the most senior person in the room probably. Not just in age, Daniel. And he was telling me about how he was trying to rewrite stuff all the time still, every time he was learning something new. And I think that makes a ton of sense. Even though we might be very senior developers, we could still be very junior in a new framework or new technology. And I think that rule still applies. As we learn more, we want to start over and fix things. So that, of course, it's natural, it makes sense, but it's not great for code bases because we can't be constantly rewriting stuff. So how do we work towards making a code base where we can safely make small changes, refactor things, and actually stay happy with our code while also accepting that sometimes the code isn't exactly what we want to be? There's also another interesting question that I want to ask is, have you ever come into an existing project? Because that is an interesting experience every time I do it. Whenever I am brought into a code base, I look at that, and again, as I grow more senior, I become less critical of code bases for some reason. But probably as I had like maybe 5-6 years of experience, I would come into a code base and go, why are there generics all over the place? This is ridiculous. This is over-engineered. This is way too complicated. This is just one person going on an ego trip writing code that's way too clever. But as you become more senior, you actually realize that sometimes problems are complicated, and sometimes they do require complicated solutions. And it's more of a matter of how well could this person isolate the complexity into a certain part of the code base rather than scattering it everywhere. Right, and so there's again this sort of junior to senior journey that you go through where as you're more junior you get more frustrated about complicated things, and as you're more senior you might accept things a little bit more. So my name is Donny, and as you can hear my voice is a little bit sore today. Apologies for that, but in this talk I would like to explore more into these thoughts that I just had and these principles, and hopefully give you some tips and tricks to help you write code that will stand the test of time a little bit better and will help you to become happier as a developer. And also maybe look inward sometimes when you want to rewrite something and ask yourself, does this really need to be rewritten, or is this just me not yet fully understanding this code, or me looking at this and just wanting to use something new and exciting? So the talk's name is Responsibly, Scaling Code Bases. And code bases evolve all the time. If your code base has stopped evolving, you're probably not working on the project at all anymore. And probably you're going to abandon that and do something different. And what's interesting about this is that early on, in a code base, when you just start, it's usually just maybe 1 or 2 people working on the code, and the decisions that you make don't matter as much yet. Because maybe it's just you and a friend or you and a coworker. You know exactly what the both of you know, so you can write code and move very, very quickly without worrying about training each other on new features or discussing endlessly about things. But as the code base scales, you have to think about more people, right? You have to think about more problems. And that's what I want to focus on in the talk. And of course, there's the subtitle, Why We'd Rather Start Over, because I feel like that's an interesting side effect of scaling a code base, is that we look at things and we kind of just want to rewrite them. And we kind of don't like them anymore at some point, because we feel that it's not good enough, or we feel that we could do things more elegantly, or we feel like Swift concurrency is out now. We should use the Swift 6 language mode, so we have to change everything to work. Sometimes that just doesn't make sense, sometimes it does. So if I had known everything I know now, and I knew that 10 years ago, I would have done many things differently. And 10 years from now, I will say the same thing, and 10 years from now, I'll say the same thing. Constantly, you're learning and evolving your skill set, and you're improving yourself, and you're able to work on more complicated problems every single time. But you're also still learning new things every time. So there's always going to be something on the horizon that you're going to be learning that will make you feel like a junior all over again, which is great. And learning, I think, is an essential part of growth as a developer. Once you stop learning, you stop growing. If you have 10 years of experience doing the exact same thing over and over and over again, you could argue that you have 1 year of experience 10 times. You're really, really good at the one thing, which could be exactly what you were going for, be an expert at one thing and just be the best at that. But you could also try new things every once in a while and make sure that over those 10 years, you've seen 10 years worth of problems, technologies, experiences, and all of that. And as you're learning, what looks complicated and over-engineered to you right now might actually look really reasonable in the future. Because without any context and without the experience that whoever wrote a piece of code has, you might not be sure why the code was written that way. And I think it's very important that if we look at code that we didn't write ourselves, that we start reading that and that we're open to learning the why behind the code. And ideally, learning the why is easy. Maybe there's documentation, maybe there's a wiki, maybe there's still an engineer around who can actually walk you through the code and explain everything. I'm not saying that all complex code has a good reason to be as complex as it is. Sometimes it's just somebody going on that ego trip and writing something to show off that they know generics and all the other complicated things. But other times, somebody tried to solve a really complicated problem, and they actually did a really good job isolating complexity into one spot, allowing the rest of the code base to be simple and easy to reason about. Right, because a while ago, actually not that long ago, I wrote some code that allowed me to recursively receive events when I changed a property on an object that was an observable object and it held a bunch of options. And as you might know, observable object has published properties, and whenever one of these properties change, you're told about it. But if one of those published properties itself is an observable object, then you're not notified about changes to that object. Let me actually just show you some code to make that a little bit clearer. We have that final class oscillator at the bottom. Basically, if somebody changed cycles that float, I would want to know by the note telling me. That's not possible by default. By default, you would only be told if you assign something new to any of the properties on note. Caller properties only tells you about its properties, and oscillator only tells you about its properties. But in my use case, I needed to be able to say when anything at all related to this note changes, I want to know about that. So that's my objective. Allow changes to the innermost object to fire the outermost object, the notes. Object will change publisher, or something similar. Because of course I can't change how Apple wrote. Object will change, so I'll probably have to do something of myself. Now the simplest solution I could come up with was to just write a list of all the properties I was interested in by just looking at every class involved and going ahead and writing a list of things. So if you're familiar with Combine, this should look fine to you. If you're not familiar with Combine, there's publishers merge many, and that takes a publisher, a list of publishers, and it pushes them all into a single one. So that's great. I can list every single property that I'm interested in. This has problems. right? This is the simplest thing, and anybody, no matter your experience level, can read this and more or less understand what this does. But it requires developers to remember that there's some place where they need to add or remove properties whenever they make changes to any of the objects related to my node. That's just something that will go wrong at some point. It's very error prone, right? If I forget one property, it looks fine, everything compiles, but I'm not observing one specific property, so when I change that, I'm not told about it, I have a bug in my application. And this list was only a fraction of what I would have written if I had actually gone ahead with this. I think there would have been about 80 properties in total, because it's a pretty big data model, it's pretty complex, so it would have been really, really big. So this code would really never ever scale well. Right? This would have been a quick solution to a problem that I had, but it would have not been a good idea to keep that in the code base. So the solution that I chose was to write a protocol called will update publishing. And my plan was, when I thought of this, that I'm going to make objects that I want to sort of recurse into other objects, conform to this protocol. So if oscillator conforms to will update publishing, then it can tell whoever owns it that it has changed, and so forth. So this already, just thinking of this, made this into a really complicated problem for me. Because how do we do this? Well, I went ahead and I wrote that code. And it looked like this. And this slide is going to be up for about 30 to 60 seconds. I don't expect you to read or understand this code. I just hope that you're noticing that there are some really strange things happening here, like I'm using reflection, for example. Who here loves reflection? Please keep your hands down, because nobody does. But it's actually a valid solution to certain problems. Like in this case, at runtime, I wanted to inspect all the properties that existed on an object, see if they are will update publishing and observable. If they are, go deeper and find everything that I'm interested in, and build that merge many publisher automatically without me having to manually maintain it. So this is complicated code, and you could say, Donny, that was you on an ego trip. You wanted to show that you know reflection. Maybe it was. But in my opinion, this code was not necessarily harmful, because this allowed me to put something really complicated into one file with documentation and tests, and allows other developers on the same project to solve this complicated problem simply by conforming to a protocol. So to me, this was an example of something that's super isolated, something that's relatively small, but solves a really complicated problem in a way that scales well and allows other developers to use this without worrying too much about the implementation details. And if I were to write this again, I might not go for reflection. I might try using a macro, or I might use code generation like sorcery to do this in a different way. However, I think macros and sorcery both would still result in something that's relatively complicated. So it wouldn't make the code simpler. It would just not use reflection and solve the problem at compile time rather than at runtime, which would perform a little bit better. So complexity and over-engineering can look different depending on skill level. To people that are familiar with reflection, this probably looks maybe like not the best solution, but they would get it. To somebody who's more junior, and I actually worked with a junior developer on this specific project, I had to walk them through a couple times before they understood what it did, and before they realized that probably the only time they would look at the code was the time that I put it in a PR, and I had to tell them what it did. After that, I think it's been in production now for 3 months. Nobody's touched it since. Nobody's had to look at it since, because it works. We know it works. We know what it does, and we know why we have that code. I also showed this code to some friends of mine who are more senior, and they actually said you should open source this because it solves a problem everybody has, but I'm not doing that because I'm too embarrassed about the mirrors in there. So, coming back to skill level and rewriting. When I was at the beginning of my career, I loved to rewrite things. It was one of my favorite things to do. Basically, when I got into a new project, I would find a feature that I was interested in figuring out how it works, and I would just rebuild it from scratch. My goal really wasn't to make it simpler, better, or get that merged. My goal was to pick it apart so I could understand it. Nowadays, I'm less inclined to do that, but I think it's still a good idea. And what's also interesting is that as I rewrite now, I often quickly see why the code is the way it is, whereas in the past, I would often think, so when am I going to need that complicated part of the code? Because it feels like I can solve everything easily. And that's when I kind of realized as I was working on this talk and thinking about these stories for myself and asking other people about what they did, is that skill and confidence come somewhat as a bell curve. Because you're just starting out, you have not as much skill and knowledge yet, but your confidence is also low because you're aware that you don't know that much. A couple of years in, you've learned a lot, and you're actually a pretty good engineer probably. And you look at these people who have 20 years of experience and the code they write, and you think, I can do all these things. In fact, I might even be a little bit further along than they are, because I've learned Swift UI in the meantime. I know Swift concurrency really well. I know Swift data, and they don't even know that stuff yet. And so you kind of get to that point where you think you know a lot, and you want to start introducing these new things that you've learned, and you want to start refactoring code, because there's all these new tools available that are so much better than what we have now. But then as you progress more, you actually realize that there isn't really that much need to refactor or rewrite existing code. One example of that is a project I worked on is a very big app, and it's been around for probably as long as iOS has been around. And the very core of that application, the part that makes the application into what it is written in Objective-C. And it hasn't been touched probably in a couple of years, other than maybe very minor refactorings. And when I first looked at that code base, even just a year or two ago, I was like, we should probably fix that Objective-C part. Until they told me, just wait, you'll see that nobody touches this, it works, and why would you rewrite something that actually works? Now there are risks associated with that thought, right? Eventually there will be no Objective-C developers left in the project, and they will have to hire somebody that's extremely expensive to even fix the most minor things. Topic for another talk. But what I'm trying to say is you kind of learn to accept that some pieces of the code base are weird or complicated or outdated, and you kind of learn that that's just fine. Somebody wrote that, they probably knew what they were doing, you have bigger things to focus on. Whereas maybe in the middle of the curve, you're more motivated to change that stuff. And also what's interesting about a rewrite is it's a clean slate. We can rebuild the code and our understanding at the exact same time. So no matter what you do, the rewrite could actually be very appealing. You've learned so much lessons, and you want to implement those lessons, and you want to make the code better, more stable. But unfortunately, the clean slate is often not as clean as we'd hope to be, because if we're doing this in a business setting, business owners get very nervous when you tell them, I'm not going to ship anything for the next 6 months because I want to rebuild the app. And they ask you, well, do we have problems with the app? Yeah, it's just the code is so outdated and I don't like it anymore, so I want to rewrite everything, it'll be better. Okay, but do we have performance problems? Not really, but it could be better. Do we have crash problems? Not really, but it could be better. So does it take 6 months of doing nothing to fix that? Probably not. And do you really assume that your rewrite is going to be free of bugs and crashes? Because I don't think it will be, especially once time pressure starts to kick in. You really have to start shipping this. You're going to cut corners. But still, replication is a great way to learn. When we copy, we learn, right? It's how artists learn how to draw. It's how Hidde learned how to make apps. Right, Hidde? Yeah. It's how musicians learn how to play their instruments, right? If you pick up piano, guitar, whatever you're interested in, you're going to be playing music that other people wrote. You're going to be replicating that. So why should code be any different? It makes total sense that we look at UI, that we look at code, and we rebuild it to understand how it works. But sometimes rewriting is not the best way to improve something, right? So we need to make sure that we don't fall into the trap of thinking that the second time we write something, it's for sure going to be much, much better than the first time. It can be, but not always. Let's also talk about complexity a little bit more, because I think that's a very interesting aspect of scaling code bases. And no matter how much we try to refactor, no matter how much we try to keep things simple, there will be complexity in your code base. Maybe not in the shape of the actual code you wrote, but it could also be in project size. Because complexity can hide in lots of corners, and the size of your code base could be it, but it also could be over-abstracting or over-engineering. And whenever you introduce that, it's always a bit of a trade-off. Right? Even when you introduce something like Swiftlint, that is complexity. That is a new thing that people have to install and understand and use, because it's going to give you warnings or errors. So they have to understand this. They have to work with this. And it's tiny, but it is complexity. Same is true for a lightweight architecture. If you implement something like MVVM and you don't go like super theoretical on it, you just say, here's the view model and kind of what it's supposed to do, go for it. That is still complexity, because it's something people have to learn. Dependencies like TCA or reactive programming, for example with RxSwift, they set a much higher knowledge base for your code base. Right? Even though they don't necessarily make your code more complicated, they certainly make your project a lot more complicated. Because now whoever you bring into the team, they have to know TCA or RxSwift or whatever it is that you introduced. Generics abstractions and code generations are convenient, but also, again, they are complexities. They can be used to solve really complicated problems, and when well isolated, they could actually not touch too much of your code base, but it becomes part of your code base, and it is complexity. And even if you manage to stay away from things like dependencies and generics and all these things, your project grows. The Xcode project becomes huge. You have lots of files, lots of classes, and just lots of things to know and to deal with. And at some point, you might even find that not everybody on the entire team will know everything about the code base, so you start making sub-teams where certain people know a lot about tiny parts of the code base. And if you're not careful about project size, at some point somebody's going to say, I kind of have no idea what's supposed to go where. I have no idea what talks to what. And if you weren't careful about how you used shared instances or singletons or passed dependencies around, you're probably going to have a code base that's both huge, where everything depends on everything and everything talks to everything, and nobody really knows what the boundaries of the objects are anymore. And so that can be really tricky. Once you're in that situation, and you say, let's rewrite that code base, well, good luck, because you're going to have to pick apart many, many things. You're going to have to pick them apart in some way, but I would say don't throw away your code, but try something else, like maybe modularizing your code. Modularizing your code can really help to break apart the big project into tiny chunks, right? So if you're scaling from a 2 or 3 person operation into a maybe 30, 40, 50 person operation, you're going to want to make sure that not everybody has to know everything about all parts of the code. And ideally that they don't even have to open the project for everything in the code. But if you overdo this one, modularization, you're going to end up with a situation where nobody really knows what goes where anymore. And I've actually seen this happen on a project that wanted to get really, really big, and they were working on scaling themselves up to support many engineers. And they were looking at companies like Airbnb or Spotify to see how they are solving problems. And they came up with ideas as, okay, we'll have feature modules, but a feature module should not depend on another feature module, so we'll have interface modules in between, which is something that Airbnb does. And they had this whole big setup, and they kind of demoed this to the team. And you could just see everybody goes, oh my God, I do not want to build new features, because I do not know how many modules I have to make, which modules I have to make, and I do not know what would go where. Like, you could just see the entire team's confidence drop in an instant because nobody knew what would be going on. And I think that kind of goes into the lesson of not wanting to run ahead towards your targets too much. You know your code base is going to grow, but don't pretend you're already Airbnb when you're a team of 15 people, because you're nowhere close. I think Airbnb is more like 150 to 300 people working on the same app, so you're not close yet. Now, if you do want to modularize, you could do something that I call modularization light. And what that means is that you're not really making any modules at all, actually. You're just still using a single Xcode project. But you are writing code with very clear API boundaries and with predictable APIs. So you make sure that you make things private when they should be private. You make sure that you make things internal when they should be internal. And why not just mark things public ahead of time? Right? You're not using modules yet, but maybe you will in the future. So marking something as public is a very clear signal that you're saying, this is okay for other objects to use. And always make dependencies explicit. Even when you're depending on a shared instance, make sure you pass it to an initializer. You will thank yourself later when you start to actually make some modules, or when you want to change things up a little bit. Because if you have shared instances all over your code, you don't know what depends on what, and everything starts to talk to everything, and you end up with the same big mess that you would have otherwise. And if you do these things correctly, you can actually start to move these things into SPM modules or Xcode frameworks or whatever you prefer with relative ease. I'm not saying it will be easy, but it will be simpler than when you didn't think about it at all. And I really can't overstate how big of a barrier project size can be for people that just enter into your project and start refactoring. So making sure that your project is browsable, even at a large size, can be a huge help for people that want to understand the code base. And what I mean by that is make sure that you have nice groups in Xcode, that you have great file names, that you don't just throw 6 or 7 classes into a single file because you felt it was too much work to make a file for a class that only has like 10 lines of code. Why not? It's not like we're paying by the file. Just make the file. It'll be much easier for somebody looking at the Explorer in Xcode to see what's in there. Naming things properly is also a good suggestion. Adding some comments. I know who here believes in self-documenting code. I am very much against self-documenting code because code can tell me what it does, but it does a pretty terrible job at telling me why it does that or how I'm intended to use something. If you can have some tests as well, that's great. And you'll definitely make it better when somebody wants to explore your enormous project. And sometimes projects just get big, right? Same with sometimes problems are just complicated. Sometimes things just are big, and sometimes you just need some time to digest. And if that's the case for your code base, I would suggest that you write a little guide to help somebody that's new in the team to point them towards the important parts of the code base. What's that Objective-C module you have in your code base that nobody really touches? Because odds are that's the first thing that your new junior developer sees, and they're going to be scared that they're going to have to work on that. But maybe that's just a stable part of your code. So some documentation, some onboarding can really help out here. Now, another topic that I find very interesting, or found very interesting, or did a lot with when I was just starting out, is that new and shiny was always better in my opinion. I would come in and look at a code base and go, oh, but this thing uses a table view. We can use collection view now, so we should move to that. And I would do that. I would just rewrite the code, use a collection view, and I would have new bugs, new problems, and some feature that I didn't really know existed or kind of assume nobody used, like maybe swiping to delete. It's like, remove swipe to delete. Nobody uses that. First thing you get as soon as you ship that, why is swipe to delete gone? Like, oh, yeah, we're using collection views now. Do they have swipe to delete? No, they didn't. Well, it's not ideal, right? So maybe it makes sense to just wait things out a little bit. I love Daniel's suggestion on Swift Data yesterday. He did a 4-hour workshop on Swift Data, and then he said, you're not allowed to use this for another year or so, or at least until dub, until you make sure that Apple cares about this a lot. And I think that's great advice. Right? Swift Data is new, it's shiny, and it makes things a lot easier in certain ways, but it also has shortcomings, bugs, missing features, and only 1 year of experience where Apple doesn't even really make big changes during a year, right? So it only has had one major release cycle. So it makes sense to wait these things out. It makes sense to experiment with them as well, to see what would it be like to use this in the code base. But I wouldn't push too hard on using new and shiny things too fast. Even Swift UI today for some code bases just doesn't make complete sense yet, which after 5 years is pretty interesting in my opinion. And I also said this before, don't optimize for what you don't need yet, right? If you're a 5-person team, a 10-person team, and you want to become the next Facebook, that's great, but don't act like it yet. You're not Facebook. You're only going to make everybody's life harder if you're going to implement Facebook-style processes, Facebook way of working in an app that is tiny and supposed to be lean and quick and easy to work on. Right, so work towards it. Don't forget that you want to get there, but don't pretend like you're already there. And now as you scale your code base, tech debt is real. A growing code base will almost always incur tech debt. I have not seen a single code base that was free of tech debt 100%. Could be large, could be small. Your experience could be 10 years or 1 month. You will cut corners. You'll have deadlines, you'll have problems you don't know how to solve yet, and you will fix things. Just like we saw with the scroll view demo yesterday, fixing that problem, it's a solution to a problem, but it also introduced a little bit of tech debt where this is now something that needs to be maintained and might not work in a future iOS release. And that makes sense. It's only natural. We have to work on our code bases. We have to ship things. We have to fix things sometimes. We have to cut these corners every once in a while. And a more experienced developer, in theory, will have a better sense of the impact of code base, of tech debt on a code base than a more junior developer. And I think there's a serious role for senior developers to look at code in a pull request, for example, that was made by a junior developer and say, hey, this is some tech debt, and I think we should address that as soon as possible, and help the junior developer with assessing the impact and the timeline in which the tech debt should be fixed. Make sure that a Jira ticket is created if that's what you're using, and make sure that you understand the impact of it, the risks that you're taking on, and ideally also some sense of when can we fix this, or how can we fix this, or how much time would it take to investigate this to get rid of the tech debt. Because tech debt really doesn't just go away. If we don't actively work towards getting rid of tech debt or paying our debts, then they will just stack up and they will get worse and worse. If you wrote some API that took a little shortcut and somebody else sees that, then they go, oh, I could actually just call that because it solves a problem I have to solve for this other feature. Now other people in the code base are using your tech debt thing, and if that spirals out of control, you're looking at a larger and larger and larger refactor every time that happens. So whenever you introduce tech debt and you're aware of that, try to immediately think of that timeline. How and when can I fix this? Because the sooner you fix it, the better. And of course, you can't always just fix it. Sometimes you have to wait for Apple to fix something in an iOS update before you can properly get rid of your debt. But know that that's what you need. If you don't know that that's what you need, you're probably never going to get rid of it. And rewriting code is not necessarily paying your debt. Right? I've been on projects where the argument was we have so much tech debt, it only makes sense to declare tech bankruptcy and just start over. And sure, that is a way to sort of get rid of a big mess that you've created and just start fresh and have a clear mind and solve problems all over again. But like I said, business owners get nervous when you tell them, I'm not going to ship anything for you for a really long time. So that puts you under pressure, and guess what pressure helps create? New tech debt. So all you're doing is making new debt. Sometimes it makes sense, but often it's this looming green field of a rewrite that makes it feel like you're going to start fresh without any tech debt. You will have tech debt. It'll just be new debt. And I've also seen rewrites get out of hand where they were paying tech debt, but they were using new technology at the same time, and crash rates would go up a little bit, and they would be almost there. So project managers, C-level people would go, okay, so I see that like the app's almost done. When can we ship? And the developers would say the famous, oh no, we're 80% of the way done, but that took only 20% of the time. So the next 80% of our time is going to be for the last little bit. And you really want to avoid this because everybody gets nervous when that happens and nobody's happy in the end. And it's all a process, right? Writing code, leveling up as an engineer, scaling to new and never seen before team sizes and app sizes. It's all a matter of learning and adapting. I think we've all seen posts by companies like Airbnb every 2 or 3 years where they tried something new, they went all in, and they said, we were completely wrong, we're going to try this other thing now. And in 2 years, they'll write a new post saying, we were wrong about that, we're going to try this other way. Know that they're never, ever completely rebuilding their code base. They're always moving towards something new, trying it out, going all in, refactoring, but never completely rewriting. It's also a good idea is to listen to your junior developers, even when they complain about things that you consider to be simple. If they're complaining about something being too complicated or not understanding a part of the code base, that's not their problem. That's your problem as a senior developer. You should document the code better. You should introduce the code base better. You should have a wiki, all of these things. You have a chance to educate your developers to help them grow along with your code base. But you shouldn't expect that if you're using something like a new language feature in Swift, that everybody will magically have learned that in their free time, right? You should make sure that you introduce this to your team, make sure that you do a little presentation maybe, write it down somewhere, make sure it's all teachable. If your code base isn't teachable, if it isn't searchable, if it isn't documented, it's going to be a bad time for everybody joining in. All right, let's wrap this up. When we grow our code bases, we often kind of know a rough direction of where the code base will go, but we're almost never exactly sure where we will be in about 2 years. Skill level impacts how we perceive a code base, right? Our skill level makes it feel like sometimes we know more, sometimes it feels like something should be simpler because we simply don't know certain language features or whatever, but it really impacts our perception of a code base. Don't optimize for a team you don't have, but definitely do not ignore where you're going. Make sure that you onboard your new team members properly. Take time to onboard people into a code base, because that helps them understand and that helps them contribute to the code base in a more meaningful way. And document your code. Your code is not as self-documenting as you want it to be. Trust me. And refactor stuff. Don't rewrite it. All right? Try to refactor bits and pieces. And sometimes, of course, you can rewrite bits and pieces of your code base. But whatever you do, try to avoid throwing it all out and starting over. It's not going to turn out as well as you hope. Thank you for listening. And a special shout out to ChatGPT for giving me a ton of images for this presentation.